Ladies and gentlemen, it is 4 p.m. on Tuesday, the 30th of March. That means it is time for a brand new epic product launch, live from Mission Control in North Bike by the Sea. For the second time this month, just ahead of Easter break, we have selected 6 epic members who each have an important development to announce to the rest of the world. Today, we are featuring Luxinar, laser components, AEMtec, Focuslight, Phasics, and LaVaCELL. So let's open up the Zoom room and get started. Ladies and gentlemen, we are live. I'm super excited today. It is the 30th of March, and most important, it is 2 days away from my Easter holidays. So I'm in the brightest mood that you have seen me in a long time. I have something really, really special for you. Six huge developments of epic. And I'm really happy to show them to you, but most important, I'm really happy to ask them the epic question and make sure they tell us what they can do for the other members and what the other members can do for them. It is all about a business connection. My name is Jose Pozo. I am the CTO, Chief Technology Observer of EPIC, EPIC, the European Photonic Industry Consortium, the largest photonic association on this very planet, but also the most exciting photonic association also on this planet. I really would like to say to everyone that this has been a really fantastic year with lots of online meetings, really horrible year outside, really fantastic year for EPIC, making the best of the online world. And we keep organizing these fantastic online technology meetings. Tomorrow I have a fantastic meeting on space technologies with companies like Minari, Tesat, talking to us about free space communication based on lasers. Write it down. It's going to be fantastic. Tomorrow with the European Space Agency. And also for the first time in 2021, EPIC also supports the Quantum Technologies Consortium. So also remember that on the 9th of April, for those of you interested in QKD, quantum key distribution, or quantum communication, or quantum internet, 9th of April, write it down. But today is our monthly EPIC members new product release. And we had together a fantastic agenda. We're going to talk about the CO2 lasers or Luxinars, the thin-film polarizer based on Trichroic for combining 2 beams for laser components, the new active alignment services of AEMtec, the Focuslight technologies based on laser diodes for beam steering LiDAR. Phasics is going to talk to us about wavefront testing solution from UV to mid-wave infrared, and LaVaCELL 450, the new turnkey machine for laser beam welding in vacuum. What a fantastic day. It's only going to take 1 hour of your time. It is going to be totally worth it. Let's go to it. Let's cut to the chase. Let's start strong. Let's start very strong. We start with Luxinar. They are presenting their SR AOM product line. They are saving heat dissipation with a new concept for high precision manufacturing. We have with us Technology Stream Manager, Billy Richards, to talk to us about their new product, and most important, for him to tell us how we can help Luxinar being already greater than already is. Billy Richards, thank you very much for being with us this afternoon. Thank you for opening the event. The floor and the attention of everyone goes to Luxinar.
Thank you very much. Good afternoon. My name is Billy Richards from Luxinar, and today I would like to present our new SR AOM range of CO2 lasers for high precision applications. So just a brief contents. First of all, I will just talk a little bit about Luxinar and then introduce our new SR AOM range of lasers, looking at the features and benefits, the performance, and then talk a little bit about some of the industries and applications which these systems are relevant to. So Luxinar has over 20 years of experience in the industrial CO2 laser technology. We rebranded in 2019 to Luxinar. Our head office is in the northeast of England, in Kingston upon Hull, and we also have offices in the USA, Germany, Italy, China, and South Korea. So our new SR AOM range of industrial CO2 lasers. So these feature an integrated acousto-optic modulator with the purpose of creating fast optical rise and fall times of less than around 1 microsecond, with the purpose of minimizing the heat affected zone, which is a problem for certain materials in processing. So they're available at wavelengths 9.3 microns with two different power levels. We have our SR10 AOM, which is available at a 75 watt output power, and our SR25 AOM with 150 watts of output power. So the fast rise and fall time of the optical pulse provides a higher quality cutting edge compared to standard pulse CO2 lasers, enabling high precision applications. And these systems all feature stabilized output power and pulse energy. So just a quick look at some of the technical data of these systems. So on the left-hand side is some typical output power stability data for the two systems. At the top is the SR25 AOM, which was running around 80 watts with a 50% duty cycle, and below that the SR10 AOM. And both of those have a power stability of better than plus or minus 1% over a 10-minute run period. On the right-hand side, you can see a typical output laser pulse. So this is a 2 microsecond long output laser pulse with a typical rise and fall time of actually less than half a microsecond. So we specify less than 1 microsecond, but typically less than half microsecond is what we achieve. So we also maintain very high quality beam output. So we guarantee the M² value to be better than 1.2 and the ellipticity to also be better than 1.2 to 1. And this, coupled with the fast pulse rise and fall time, enables the high precision machining. So just a quick look at some example applications of material processing using these lasers. So first of all, this is comparing a standard CO2 laser with a CO2 laser with integrated AOM for machining of 3-layer polarization film. So you can see on the right-hand side, the material processing with the CO2 laser with AOM produces approximately 30% less heat-affected zone compared to a standard CO2 laser with longer rise and fall time pulses. Similarly, looking at a 5-layer film here. So this is a material where you would process just partially process the material, so only some of the layers of the film you would want to process. A problem that can occur with these materials is that the layers will melt and stick together to the neighboring layers. But using a Luxinar SR25 AOM laser here, you can see that you get a much cleaner cut quality compared to a standard CO2 laser. And finally, it's a similar story here with heat-sensitive indium tin oxide layers. So they can suffer discoloration and also poor cut quality using long rise and fall time pulse CO2 lasers. And again, here we saw a vast improvement in the cut quality using an AOM laser. So applications that these systems may find themselves useful for include microfilm cutting in the flat panel display market. So for example, backlighting unit is a very common material that is processed using these systems. Any kind of scribing, engraving, marking, or surface patterning application that needs a reduced heat affected zone. So depending on the particular material that's being processed, this can be very important. And then other thin film applications, such as those in the automotive, electronics, lighting, flexible packaging, and flexible printing industries. And again, kiss cutting is a very common application for these systems. So just quickly in summary, this is Luxinar's new SR AOM range of CO2 lasers with very fast optical rise and fall times of less than 1 microsecond for high precision processing, energy control, and reduced heat affected zone. Available at wavelengths of 9.3 microns and power levels of 75 watts and 150 watts. Pulse widths available are from 2 microseconds all the way up to CW, and they incorporate power loop controller standard for enhanced stability. So with that, I'd just like to thank you very much for your attention and invite you to contact us if you would be interested in any further information. Thank you very much.
The name was Billy, but the email address here is yannick.galais@luxinar.com. Contact them for getting more information on this fantastic product line. But Billy Richards, today we are in an epic meeting, and you know what it means? It means cooperations. You get the epic question. What can you do for them? What can they do for you?
Well, so at Luxinar, we are able to provide very, very high quality lasers for industrial applications. So, you know, we have a wide range of CO2 lasers for power levels from, as I mentioned here, 75 watts all the way up to over a kilowatt. We're also in the process of developing a solid-state laser at near-infrared wavelengths for new applications. And in terms of what members can do for us is really tell us what they need so that we can start looking at our next line of products.
Thank you very much, Billy. We have a question from one of the key companies in EPIC on optics manufacturing, Edmund Optics. Dragan Velkov, what's on your mind?
Well, we don't have necessarily application right now for CO2 lasers, for applications with what we do. I just wonder, you spoke about the weight of the as you do the processing and so on. So I wonder, outside of your laser, what kind of delivery system you have? Do you have a combination of, I don't know, beam spanner and scanner and some mirrors that you use in order to deliver the system to the target, or is that part of your portfolio, or you kind of work with other companies to make it happen?
Yeah, so absolutely. We provide products for so both finished products that do incorporate, for example, a Galvo scanner. So we do offer sort of complete packages that a customer could install, and typically they're used for marking, product marking. So for example, one application is marking bottles on a bottle processing line. The majority of our systems are designed to go into, be integrated into other machines that a company would build into their system and then sell on. So the OEM there would incorporate that. So we do offer both of those options.
Sure. Billy, I was very excited to see about the kind of power that you can reach with your laser, and also you talk also about the M². You actually mentioned, I think it was 1.2 in your presentation. But for many of the applications that you were targeting, it's not only about the power, but it's about the power stability. Do you have some metrics on that, some statements, something to share with us about the power stability of the AOM range?
So our guaranteed power stability from these systems is plus or minus 3%. Typically, we would achieve better than that. So typically, it's plus or minus 2% over a shorter period of time. So for example, the data I showed in the slides was over a 10-minute cycle. So we're looking at better than plus or minus 1% power stability for these systems.
We are seeing the market for laser engraving growing dramatically for larger and larger engraves, and I think that's really the sweet spot for this laser. Have you seen new applications on laser engraving, perhaps on the medical or other application fields that made you particularly excited?
Yes, so we see some new interesting applications. So we do have our sort of larger customers. So we have kind of the standard typical applications that we cater to, but we are also seeing sort of more niche and interesting applications coming in as well. And especially as we broaden our product range as well, new applications are sort of emerging all of the time.
Low heat, high precision, fantastic beam shape. If you're looking for a CO2 laser, consider the AOM line from Luxinar. Billy, it was an honor and a pleasure having you with us. It's a pity we cannot go for a beer afterwards, right? Well, let's move on to the next presentation. Let's go now to Munich, Rock City. Let's go to the city of the Laser World of Photonics, Munich. It's not happening this year. I'm crying. Let's go to laser components and talk to René Sattler. He looks fantastic with the beard. He doesn't have a beard in this picture. And he's going to talk to us about the Trichroic thin film polarizer, or what we say, how to combine two laser beams with the same or different wavelengths. The floor and the attention of everyone goes to everyone's favorite company in the photonics world, Laser Components. René, the floor is yours. René Sattler is going to talk to us about the coating that can actually make coupling of two different beams. The floor is yours.
So, hello. Can you see my screen?
Crystal clear.
Perfect. So, hello. Thank you for the invitation. My name is René Sattler, and I'm a sales engineer at Laser Components. And today I want to talk about Trichroic thin film polarizers, With those, it is possible to combine two laser beams of the same and different wavelength. So our customer came to us. So he produces laser projectors for 3 different colors. So red, green, and blue. You can see an old version of the projector here. And but there was a challenge. So the customer wants to combine 2 lasers from 2 paths. In each path, it can be 1 out of 3 colors. So it can either be red, green, or blue in each path. And in the output, customer expects to get all possible combinations of the colors. So they want to get red and green and blue and green, but also wants to have the same colors like red and green and so on. The standard approach to combine 2 lasers is a dichroid. So, but this dichroid will not work for the same colors you can see here. You may ask, why does the customer wants to combine the same colors? The answer is pretty simple. The customer wants to have his projectors pretty flexible, and to combine 2 same colors will just increase the intensity or contrast. We thought about that, how can we do that? And we had the idea we could use the polarization of the lasers. The customer said, okay, he can control the polarization of the lasers, of the red, green, and blue. So if it is possible to design a thin film polarizer working simultaneously on 3 different wavelengths, this could be the solution. So you can see here on the picture on the left-hand side, the lasers, the red, green, and blue, have all P polarization. And on the bottom, we have the 3 laser colors with S polarization. So with this thin film polarizer in the middle, you can have in the output all different combinations of the 3 wavelengths, including the same colors. You can see it indicated by the arrows and the circles with different polarizations. So we designed this trichroid thin film polarizer, and here are the coating details. So on the left-hand side, you can see the spectrum. The green line you can see is the reflection for the P polarization. So you can see in red, green, and blue wavelength range, we have low reflection. So the red, green, and blue is transmitted for the P pole. And the S pole reflection always remains on high values. So we did this coating with our IBS chamber. You can see on the right-hand side. We designed the coating for an angle of incidence for 45 degrees, so it's pretty easy for the customer to handle this component. The customer did not want to have a big displacement of the transmitted beam, so he wants to have the substrate pretty thin. So as we applied an IBS coating with lots of stress, we had also to apply on the backside a stress compensation coating to maintain the good surface figure from the substrate. So in the end, we will also increase our capacity for such coatings because we will get a large IBS chamber in this summer. With this large chamber, it is possible to produce several hundred pieces of this trichroid thin film polarizer in one coating run. So with this, I'm already coming to the conclusion. We at Laser Components, we have well-educated sales engineers here. We understand customers' challenges and find solutions. All our coating development we do here, and also the complete machine park, is driven by customers' needs. And of course, what I showed you before is just one example, and there are many, many more. So you can say we are specialized in challenging demands and apparently impossible inquiries. So please challenge us. It is our business. Thank you for your attention. And if you have questions, please let me know.
r.sattler@lasercomponents.com. Contact René if you want to know more about this fantastic development. I want to know more about this fantastic development, René. But first, I want you to answer the epic question. What can you do for them and vice versa?
So, yeah, as I said, Laser Components is specialized on customized optics. So we need to know what you need, and then we can talk about that and find solutions. So yeah, the idea, what can you do for me? Spreading the idea of doing customized optics. So, and giving us input on what is needed and what can we do for you. We can possibly find solutions for your problems.
Of course, and you found a lot of solutions for many of the EPIC members' problems. So congratulations on that. We are having here a polarizer, a Trichroic polarizer that can do effectively beam combination. The question here is, of course, what kind of powers can this coating face? Are we limited in the maximum output power of the lasers?
Yeah, of course, you're always limited in the output power that you can apply. So here it is a pretty thick coating, so a very complex coating with lots of layers. So normally when you have lots of layers, complex coatings, the LIDT goes down a bit, but in the end, it's a high power coating. All we do are high power coatings here. So, but perhaps it's not that high power than you would expect from a normal high reflective mirror for 1064 nanometers. So it's a bit less because of the complexity and therefore the defects you have in the coating layers.
Many companies in our network are investing heavily on IBS machines. This is something that is happening worldwide, but I think especially in Europe for manufacturing high-end optics, high-end laser optics. One of the key applications have been the ultra-fast laser, the beams with high fluence. I have one of the companies here from that sector. I have Expla, Gredius Cubada. Thank you very much for being with us today. Thank you for being with us in the meeting. I would like to ask you, what do you have in mind and what kind of cooperation could we have with a company like Laser Components and Expla?
For me, it's interesting what is a practical application example for such components. For example, where did you already supply such components for what companies?
So this special inquiry was for a company who asked for especially combining those colors for a projector for positioning purposes. But after we did this, we also had other inquiries from in another case from a university who wants to have exactly this design, but a little bit different. So he wants to pump with several lasers in the visible range a tissue, I think a biological tissue, and collects the fluorescence and also uses the polarization for the both paths. So putting the power in with the laser and getting the reflected or the fluorescence out of the tissue and use it with the same optical components. So there are many applications. So what I can also think of is perhaps like projectors for like cinema or something like this, where you want to have where you want to control the polarization, perhaps having two different pictures in one in P polarization, one in S polarization, perhaps for a 3D cinema application, things like that. So there are, I think there are a lot of applications possible, but as I said, this is just an example. It may be, or it may sound exotic, but I want to show that also such things are possible, and the ideas mainly come from our customers.
And if you have more ideas for collaboration, if you have, the sky is the limit. Think about how you need to combine these two beams. The projection is really a huge market. There are many others. Dream away and check your dreams with René. René, thank you very much for being with us. We move from laser components. Now we go to AEMtec. You know, in Europe, we have lots of companies now developing assembly and packaging solutions, but only one who is combining them also with back-end processes. We have Dan Negrea, SVP of New Technologies, to say how they are also adding active alignment for the packaging and assembly to the backend process to provide a full solution for the packaging of optoelectronic devices. Thank you, Dan, for being with us from AEMtec. We want to hear from all of us how we can help AEMtec being already greater than already is. The floor and the attention of everyone goes to Dan.
So, hello, everybody. I'm trying to match a little bit the enthusiasm and the dynamic that Jose brings in this meeting, but I'm absolutely without any chance compared to him. Jose, you're always amazing to me. So thanks a lot for this opportunity to present you a little bit of what we are doing at AEMtec. What I'm going to talk right now is about a new technology that we are introducing in our company. And I'm going to give you both a technological perspective, but also a business perspective. My name is Dan Negrea. I'm Senior Vice President for New Technologies, and I'm with AEMtec for something like 12 years or whatever. And in my presentation, I'm going to insist a lot about this E that you see here in this epic, and this is the European perspective on this business. So just a couple of words about AEMtec. I'm making it very, very short. Something like 200 people working there, 50+ million turnover. And we just managed to calculate completely wrong the facility that we built a couple of years ago when we doubled it. Right now, we are doubling again. So we are extending our facility. We are going to reach a clean room surface of 300 square meters in ISO 5 class. And this is where all the clever and new technologies are going to be placed. Then something like 1,000 square meter ISO 7, and then 1,500 square meter ISO 8. The whole thing is being built right now, so we are challenging Tesla. We are not challenging the Berlin airport. We are challenging Tesla, who builds the fastest. We are going to be ready with this by probably end of July, beginning of August. But this is just one aspect of it. AEMtec has been dedicated to highest accuracy assembly, European solution, and we are talking here clearly about small and medium quantities. Small and medium quantities means up to a couple of tens of thousands of such products a year. In worst case, or the highest level is something like a couple of hundreds of thousands. But the technology I'm going to talk about today is the active alignment that we are introducing. Where does this push come from, and what are the drivers? We had in the past, and we have right now, a lot of projects requiring alignment of optical components in the range below 1 micrometer. 1 micrometer with respect to the absolute perfect position that you can find only in your computer simulation, but never in real life. And we're talking about alignment of a VCSEL array. It's being used in a 400 gigabit transducer. It's a 5-axis alignment that we need to do here. It's X and Y, so placement, but also tilt around the 3 axes. The Z position is given by the height of the bumps where we make the contacts. And one of the main challenges that we had in this one is that the measurement of the position for the alignment is being done through transparency. So what you see on the picture on the left side is one of these measurements through transparency. And as you can easily recognize, there are plenty of levels of grays, shadows of yellow and gray here, which make the recognition quite tricky. At the other end, another project where we are looking at, it's a LiDAR project. We are talking here about placement of multiple elements within 1 micron away from the absolute precision. So definitely not simple things to do. That's the reason why we decided that we have to go one step ahead. In the past, we were fully believers that passive alignment is probably the best thing that you can do. But definitely we learned better. Also, because one key driver, and I'm going to talk about this a little bit more, even if I'm a technical guy, I'm going to talk about money. It's the cost effectiveness that we need to achieve here in order to keep Europe as a leader in this kind of packaging. So we went into a deep cooperation with AEMtec and looked at their product. And this is the product that we are about to acquire. It's a machine that has been designed by them and then modified a lot in order to have all the versatility that we need in order to get different projects correctly solved. Where are we in this process? So we are talking about the introduction of the equipment. Everybody who did it knows that the more complex the equipment is, the more difficult it is to introduce it. So starting with the first introduction, with the first setup, this is being done at AEMtec. They are putting in place the process. They make the process turn there. And at the moment when the process is ripe and we are moving to series production, then the machine moves to us and we are handling then the series production. Once the machine is there, then we are going to go to the typical qualification process, the IQ, OQ, and PQ, where, of course, we are counting also on having several months of hard work up to the moment when we get it. So this is going to be, from a time perspective, this is going to be in the third quarter of this year, where the clean room is already extended and the machine has its new emplacement. And we expect to be full scale available for taking projects by end of 2021. Now, I told you I'm a technical guy, but I'm going to talk a little bit about money here. Why the hell did we buy this machine? Well, first of them, you want to have the accuracy solved, which is something that is definitely a challenge by itself. But there is a financial aspect that does make a lot of sense. And this is the following. We looked in the past at the costs for microns. How many euro does a micron cost? And the surprise is the less microns that you are talking, the more expensive it gets. In the graphic that you have here on this slide, you are going to see on the x-axis is the distance from the absolute position, which is 0, and it is on the right side of the graph. And the curves that you see there are the cost for aligning one single component using a passive alignment. What we are targeting right now, it's the blue ellipses that you see there, which means same accuracy or even a better accuracy, but at a more reasonable cost. How does this work? Well, it works because despite the fact that the active alignment equipment is much more expensive, depreciation is much higher. If you are considering the whole ecosystem, if you are considering the whole environment, it is the speed that makes the difference. So the game changer that we are going to have here is the speed with which we can achieve this accuracy in the placement. Normally I get Jose, I make him nervous because I always talk too long. So this time I decided to have really just a couple of slides, but I'm ending right now with a wrap up. So AEMtec. We're targeting the sub-micron applications. We are targeting in a cost-efficient manner. I'm insisting on this one. Focusing clearly on the low and the medium quantities. And of course, made in Europe. Why should you work with us? Because if you are going into business with us, you can take really the best of two worlds. One of them is that you have the competence of a technology organization. Our people are really dreaming technology. But on the other hand, this technology comes in the whole package in an industrial-based company, which means all the business processes which are behind, all the worries that I don't know what kind of ship is navigating across the Suez Channel and not along the Suez Channel. All these worries which are related to the business and the function of the company, they are already taken care of. So highest technology possible, but in a perfect organization, being able to serve series production. 3, 2, 1, I'm done. So thank you.
3, 2, 1, I'm done. Thank you very much, Dan, for being with us today. It is really quite fascinating. I would like to ask you many things, but the first thing is obvious, right? Epic meeting, epic question. What can you do for them? What can they do for you?
So from our perspective, this is a new service that you are providing, and I'm insisting if you want accuracy and if you want reasonable cost for small and medium quantities, give us a call. We are definitely able to perform, probably considering the whole environment, much better than a lot of Asian competitors. So really it is this drive for an European solution that we are looking at. So placing any kind of crazy components, talking from, I don't know, MEMS that you cannot touch, or if you just look at them in an ugly manner, they are broken. So placing from here to anything that is requiring this kind of extreme accuracy. We are probably the partners here.
Question for you from renowned ultra-fast laser company Expla. Giedrius, what do you have in mind?
As I understood, these systems, automated systems, can be used for alignment of other systems.
Yes, sir.
Correct?
Yes, sir.
So it is interesting for me to know, is it possible to use them for small systems like lasers to align?
Of course. So we are placing, so VCSELs is probably one of the components that we are placing in most cases. But the way we acquire this machine is a machine which is open, that has an infrastructure permitting this very, very accurate positioning. And how and what we are positioning is something that can be, the machine can be customized to fit this kind of application. I would say, Giedrius, let's have a discussion directly offline about what would you like to align, because probably we are able to find a solution.
Thank you very much, Dan. I know this machine very well, and I know that Tobias Müller, CTO of AEMtec, is watching us. So I need to ask this question on his behalf. There are many suppliers of active alignment equipment, and many of them come to mind, Tegema, AEMtec. So I would like to ask you, this machine has spent a lot of time of being reconfigurable, being adaptable to many different assemblies. Is that the reason why you opted for this machine? And how do you want to use that reconfigurability part?
This is exactly the point. So the reason why we looked into this machine is because we are facing a lot of completely different challenges. And you cannot face different challenges if they are in the small and medium quantities. You cannot face them having a dedicated machine for each one of them. It simply doesn't pay. This is the key reason why we went to AEMtec, to Tobias, because we said, listen, you have a machine that we can configure together with you as we need it, so that we are able to fit different projects in a very high exchange rate. So the pace of changing from one product to another is very good. In other words, today I'm making one product, tomorrow I can make another product, and the machine is able to handle this. So it is simply this versatility that we were mainly looking at.
One of the biggest challenges that we are seeing.
Absolutely key.
One of the biggest challenges that we are seeing for the active alignment on the silicon photonics is to align fiber arrays. Fiber arrays with more than 8 fibers is becoming a challenge. In there, you need 3 degrees of alignment. Is that something that you are looking with this machine to have? Does it have some kind of hexapods inside to achieve this 6 axis?
Absolutely. So the first example that I gave you is an example where we have to achieve the alignment on 5 axes. And it's not an 8 fiber, it is a 10 channels VCSEL that we are placing there. And this 10 channel VCSEL needs to be aligned X and Y. And then, of course, the tilt in each one of this direction. Hopefully you can see I'm a little bit Latin in this respect, Jose, trying to talk a lot with my hands. So this kind of alignment, you can do it only if you have, in addition to the rest of the machine, you have a clever hexapod. Every hexapod is clever, but you have to have it cleverly controlled so that it allows you to adjust the different aspects of the placement.
Congratulations on what you're achieving. I'm also a little bit Latin talking to my hands. I don't know if you noticed. Thank you very much for this, because we need these kind of success stories in Europe. We moved from Dan, Negrea, my friend Dan, congratulations. We moved from Dan to one company that always makes me excited, Focuslight. After the acquisition of Limo, they provide the laser diodes and the micro optics, and they can do with this combination amazing things like beam steering LiDAR. Let's hear from the new product, Focuslight BeamRazor. And with us, we have She He, product manager for the LiDAR line of Focuslight. The floor and the attention of everyone goes to one of my favorite laser diode companies in the whole world, goes to Focuslight. She He is with us, and he's the product manager.
Yes, thank you, and thank you for your invitation. And my name is He Zhe, and the project manager and the Focuslight. And today is my honor to present to you the latest progress of light laser transmit module for beam steering LiDAR. And last year in 2020, Focuslight had launched an innovative light laser beam for beam steering LiDAR. This is very useful because Focuslight has proposed a solution with a uniform light laser beam, which has minimum moving parts and better manufacturability and reliability for automotive applications. And Focuslight believes that the combination of these light laser transmitters and receivers, such as SPD array or silicon photo multipliers array, could be an ideal cup for long-term detection. And Focuslight light laser transmit module named BeamRazor series can provide excellent performance. So you can see that the newly released module named AEMtec has a large range of power and divergence choices. The peak power is up to 700 watts with a frequency from 10 kilohertz to 50 kilohertz. And the pulse width is around 5 nanoseconds. And the divergence in horizontal and vertical diverse directions could be customized. And with such a high peak power, the module size is quite small, or even smaller than a credit card. And okay, in the horizontal direction, using Focuslight fast access collimation lenses, divergence of laser diode could be squeezed from 30 degrees to smaller than 0.4 degree, or even lower than 0.1 degree according to customers' specifications. And in the other directions, Focuslight recommends the diffuser or homogenizer, which has very high uniformity up to 90% and can realize large FLV design. And all these lenses are very, very suitable for outgrade application. And in this part, I want to give you an examination. So we wanted to characterize the optical stability. We have monitored the variation of divergence and the large temperature range from minus 40 degrees to 110 degrees. So the variation of the divergence is due to the mismatch of the CTE of multiple materials. So smart material selection and optimization of optical design and processes could help to reduce this variation. And by now, Focuslight has modified the configuration to obtain very small variation of these changes. And I'll go to other slide. And for this part, it's very important because the reliability of the module is another critical topic for automotive application. And we have started the tests such as the temperature cycle tests and vibration tests. And by now, the test results demonstrate that the divergence has little changes. And this test is still ongoing. And maybe for the next time, we could share more data for you. So this is the brief introduction of this newly released module. So at last, I will give you a brief introduction of Focuslight. The Focuslight technology was founded in 2007, and is a great global provider of high-power laser diodes, micro-optics, and photonics application solutions. And right now, Focuslight has 4 facilities situated in China and in Germany. And in 2020, Focuslight has launched the world's first full solid-state 3D flash LiDAR laser module named AL01. It's in mass production for the level tier 1. And in the same year, Focuslight has obtained the official certificate IATF 16949. And in the LiDAR market, the Focuslight can provide a lot of services, including optical components and laser transmitters, and as well as sampling services. So by the way, the LiDAR system is not included in this business. So that's all for my presentation, and thanks for attending. And if you have any questions or demands, please don't hesitate to come to us. So thank you.
This is your WeChat QR code. And of course, you also have an email address, which is in the slides. If you want to get in touch with any of the participants today, please don't hesitate to contact me and I will introduce you to any of the participants. But it is an epic meeting. So you know what's coming, right? The epic question. Yeah. What is your answer?
So for this our module, L02 is very useful for LiDAR application. We think that the combination of the we think that this is a very good solution, because compared with the mechanical rotating LiDAR, use multiple laser sources. So to replace this complex laser proposal, Focuslight provides a solution much simple and much efficiency. And so this one is just use one single light beam, and it's very useful. And then we can just use a rotating mirror or one-dimensional MEMS to combine with the transmitter, and this is very useful. And then for the receiver, we can use SPAD array or other receivers. And right now we have a lot of projects with our customers for customizing the light laser beam transmitters. Yes.
For me, this is a fantastic solution for 3D scanning in general, not just for LiDAR, but in general for 3D scanning. We're talking about LiDAR today. Are we talking about LiDAR for automotive?
Yes, that's right. But our proposal is not only focused on LiDAR, not only for automotive application. It can also be used in industrial sensing or 3D sensing. That's also possible. Yes.
So when we talk about LiDAR for automotive, is this process already automotively qualified? Can we put this light source and these micro optics and detectors already in automotive today, or is there a need for automotive qualification of the product?
So for this module, we are ongoing for the qualification, because it needs more data and need more tests to do. And we have the confidence to provide high quality and low cost module for our automotive customers. Yes.
One thing that was for me quite interesting when I saw this slide is the temperature stability, and to see that it's after 50, 60 degrees that you do have quite an increase. What is the limiting factor here? Is it the glue that you have used? Is it the temperature stability of the laser diode?
This means that the divergence of the horizontal axis will changes and the large temperature range. So if you wanted to keep the performance of the LiDAR very stable, and you should reduce this variation as low as possible. So right now we are just to figure out some engineering ways to reduce these factors. Yes.
You are looking for a partner to make laser scanning solutions based on micro optics, high-end micro optics, European micro optics from Limo, and fantastic laser diodes. You go to Focuslight. Thank you so much, CSCA, for being with us. And let's continue with this fantastic show. We only have 2 presentations left. Everything that is fantastic has to come eventually to an end. Still 2 presentations. The first one is from a company that we all love. When we talk about wavefront sensors, we all love Phasics. When we talk about adaptive optics, I get goosebumps. Thank you very much today, Nolan Chang, for presenting a new product, which is the Kaleo Kit, which is going to give us wavefront sensing from UV to mid-wave infrared. Nolan, the floor and the attention of everyone goes to the wavefront sensors of Phasics. And Nolan is with us here, sharing the screen, crystal clear. slideshow mode so we can see it all
Thanks
fantastic.
for
Yes,
the
the floor is yours.
introduction. All right, thanks, Jose. So I'm Nolan from Phasics, and I wanted to present today our brand new product that is Kaleo Kit, and I'll go into details a bit later on. So I start with a few words about the company. So Phasics is a French company just in the south of Paris that was created in 2003. We're about 40 employees, and our core competency is providing high-resolution wavefront measurement solutions for UV to IR. So our main technology that we use in all of our products is called quadri-wave lateral shearing interferometry, or QWLSI, and I'll explain just now how it works. So our systems, our wavefront sensors, are based on the combination of two main components. One is the diffractive grating that we call also modified Harman mask, and the other one is a sensor that can be from any technologies like CCD, CMOS, InGaAs, etc., to adapt to the wavelengths that you want to test. So how it works is basically that when you send incident light, like for example, a flat wavefront or a distorted wavefront, it will be diffracted by the grating, and after that, most of the energy will be put in the first orders of diffraction, so plus and minus 1 along the x and y axis. Now, these four replicas of the beam will then propagate and interfere on the sensor. And what we analyze is basically the modulation of frequency on the raw image of the camera that is here, that we call interferogram. If the wavefront is perfectly flat, you get a periodic interferogram. But if the wavefront is distorted, then you can see actually here that on the edges, the frequency is higher, or the oscillation of the same function. So there are several advantages to using this technology. The first one is, of course, the high resolution, as you get typically more phase measurement points than when you compare with the Hartmann. So for example, we can get up to 800 times 700 phase measurement points on a sensor pupil that is roughly 14 times 16 millimeters. The second advantage is the large dynamic range that basically enables us to make not only measurements on large aberrations, but also to make direct measurements on diverging beams. This is particularly useful when you want to characterize focusing optics. And the third advantage is achromaticity. So the sensor, because it's working with diffraction and interferences, it's actually achromatic. So the final result, the final image that you get on the sensor doesn't depend on the wavelength. And using that, it's then possible to build a wavefront sensor that has the same accuracy for all wavelengths inside the sensor detection range. So what do we provide? So Phasics provides solutions for laser, optics testing, and microscopy. But today, Kaleo Kit is all about optics metrology. So we provide in optical metrology 3 levels of integration, basically. Of course, we can provide the standalone wavefront sensors that people can use and integrate in their own machines or test systems. We can also provide integrated test machines, so turnkey solutions like interferometers, still based on wavefront sensors, of course. And we can also build custom systems to adapt to the customer needs. But today, the new development that we made with Kaleo Kit is to have a solution that is in between a standalone sensor and an integrated test machine that provides actually a way to have a standard solution for most of the measurement requirements in wavefront measurement. So actually all projects are quite unique in terms of measurement configuration, single pass, double pass, conjugation as well, in terms of wavelengths, in terms of pupil diameter, and of course, in terms of accuracy. And the idea is really that with Kaleo Kit, we can adapt to that. So actually, what is Kaleo Kit? We get actually an image on the right here. There is an example, and that is based on the combination of 3 modules. These 3 modules can be seen here. So one is the sensor. The second one is then the illumination module, of course, the source that can change with the wavelengths. And the third one is what we call a beam shaping system that can be either a focusing system or a beam extender to adjust either to the numerical aperture of the sample or to the pupil diameter of the sample. And they all come with a reference mirror, either flat or spherical, to reflect the beam to create a double pass setup, basically. An example of configurations or application that you can do with this kind of system are presented here. So basically, the idea is that, for example, if I use the source, so the illumination module and the sensor, I can already characterize a telescope or basically beam expanders directly. But with the same system, I have a cost-effective solution with just plugging in an additional module. So for example, a focusing system that we can provide to characterize not only the final system, but also the mirrors, like aspheric mirrors that are inside the telescope that they want to characterize. And the idea of Kaleo Kit is really that you have a versatile solution that you can upgrade and evolve depending on your solution, so that you don't need to buy, of course, another solution every time. So just to give an overview of what we can do, I present here a couple of examples of what we've done so far in terms of modules. So of course, we use our regular wavefront sensors from UV to far infrared, but we couple to them the additional illumination modules that work and the beam expander or focusing systems. And they're all coupled with a reference mirror that typically have different qualities depending on what you require. So in conclusion, basically, Phasics is able to provide all levels right now of solutions. So for different outcomes, it can be wavefront, MTF, PSF, on and off axis testing for different configurations, single pass, double pass, or different conjugation types, and also different levels of solutions from standalone wavefront sensors to custom turnkey solutions. So this is just for, I would say, the rough information about this new product. Of course, if you want to know more, please feel free to ask questions or to visit our website or contact us by email.
Contact at Phasics.fr, as they are a fantastic French company. Thank you very much. You know what I love the most about Phasics? It's always the idea of reconfigurability and the idea of having something that is Lego oriented. And I'm a huge Lego fan, and I love this modularity that Phasics is making a difference with. Congratulations. We do have lots of companies in the wavefront sensing. On the top of my mind, Imagine Opting, Optograph. Phasics is making a difference with this modularity. Thank you very much. You know what's coming, right, Nolan? The epic question. What can you do for them? What can they do for you?
So for them, we always on lookout for new collaborations, for new products, and for new projects, of course. So if they have any measurement requests or measurement projects, we will be always glad to help them with that. For us, we're also always on the lookout for new sources or new high-end optics in terms of wavefront that we could integrate, so that we can also, I would say, complete our range, complete our Kaleo Kit, or even our integrated test machines.
Let me find you a collaborator. I love doing that. We have Dragan Velkov from Edmund Optics. Dragan, thank you very much for joining the meeting today. What do you have in mind?
Sure, I think there are several challenges, right, and so on, and so I'm looking for a sensor that can bridge actually that transition between UV and visible. Something that you can test at 355 nanometers, for example, but then you can test at 532 as well. So that I know that there are physics limitations, right, as to what you can do, but that would be something of interest. And as Jose pointed out, to Optocraft and Imagine Optic and so on, they claim that they can actually bridge that with certain uncertainty or certainty of measurements and so on. So I wonder if Phasics is looking into extending that and improving the measurement uncertainty in that area.
Actually, we have a lot of projects that go in that direction. So I think we can discuss after the meeting, because we have something that could be quite interesting if you want to measure specifically in UV and in green, typically, or even in the near IR with the same sensor.
Okay, thank you.
You really have to discuss offline, because if something makes Phasics different, is really the huge wavelength range. And you asked for the low wavelengths. I'm going to ask Nolan for the high ones. You know, there's a huge development now in Europe on the mid-infrared technologies. I'm seeing huge developments on new quantum cascade lasers all the way to 13, 14 micrometers wavelength range. I would like to ask you, what is the key application that you are seeing for the longer wavelengths, the one from 8 to 14 micrometers?
So for longer wavelengths, the one that we've seen develop over time is really the thermal imaging that goes from before was mostly defense security, and now it's getting more and more to industrial applications and also to consumer actually applications. And I think this will probably explode at any consumer application that we saw in the past.
EPIC is actually developing a market report on elevated body temperature measurements because we do believe that there's going to be a huge market coming in the years. Thank you, Nolan, for being with us. And thank you for always do reconfigurability. I would like to tell everyone that's the passion of EPIC. We aim for low volumes, customized solutions, and their reconfigurability is key. Thank you, Phasics, for this. And everything that is great has to come to an end. We have the last presentation, but I think we save one of the best for the last. We go to LaVaCELL, a very innovative and exciting company. They have a new product, a fantastic product, the LaVaCELL 450, which is a turnkey solution for laser beam welding in vacuum. And nothing less than the CEO, Christian Otten, is here to show us their new baby, LaVaCELL 450. Ladies and gentlemen, the attention of everyone should go to Christian Otten, CEO of LaVaCELL.
So thank you very much for this opportunity to show you our new product. My name is Christian Otten and I'm the founder and CEO of LaVaCELL GmbH. We are founded in 2018, so we are a quite young company as a spin-off of the FH Aachen University here in Aachen. We have now 22 employees and 18 of them are energy engineers. Our customers' relations are worldwide. For example, the last machine is sent to the US. We are located in Herzogenrath, which is very close to Aachen and very close to the border of Belgium and Netherlands. And we are here in this technology park in a good company of companies like Pulsar Photonics, Clean Laser or Amphos. And we are also part of the laser region Aachen. Our business model is to be a solution provider for welding challenges, which includes the consulting, process development, the manufacturing of B series, and to build at least, or at last, to build product-related production machines for laser beam welding in vacuum. Why should you use laser welding in vacuum or in a lower pressure? This is shown in this video. You see on the left side, normal welding process with a lot of spatters and the plasma plume. And if you reduce the ambition pressure only to 10 millibars in this example, you achieve a less smoother weld pool. And if you do a cross section, and this is the interesting part, you see that here, the normal welding on atmosphere, you have also coloring of the stainless steel, and we achieve a higher penetration depth of up to 65%, which means we can weld 1 millimeter deep in stainless steel, for example, with only 200 watt lasers. This is very economical and the less distortions and also the increase in beam quality. Our customers came mainly from the sensor industry, medical industry, and in the last years, a lot of customers from the automotive, where we weld, for example, 3D printed parts, cells, copper, a lot of, and aluminium, and mixed materials like aluminium to copper or something like that. This video shows our new product, which is a turnkey ready laser welding vacuum machine. It has a very low footprint of only 1,400 to 1,300 footprint. We built the cabinet by our own. We use back-off technology to do that. The safety is also included in back-off. We have servo motors to use to manipulate, and this is the chamber. The chambers contain a lot of stuff with image correlation, so we need the red light. So automatic finding of the seams. If you have radial welding or axial welding, you can use this motor here. We can use different gases because it's for some customers it's interesting to use helium or argon inside their parts. And this is the upper axis, the x-axis, and the z-axis is outside of the machine.
I think we are having a bit of connectivity problems.
With G-code. And this machine is very modular, so our customer can choose out of different configurations, different scanner heads, different laser sources, and that's our modular turnkey system. So thank you for your
Thank you very much, Christian, for this. You showed the video, which I think limited your graphics card a little bit, and we had a bit of problems on that. But I would like to tell everyone that I'm going to put this video accessible for everyone. To make sure that you can see it properly. Please, Christian, Otten at lava-x.de. If you want to have any contact with him, please contact them. Christian, please stop sharing your screen and let's have a nice discussion about this. I would like, first of all, to ask you something that I think by now you are expecting. The epic question. What can you do for the others and what can the others do for you?
So what we can do for the others is, if you have something to weld, we can weld it. We can really weld every metal in a very high quality, starting from 20 microns up to 40 millimeters in thickness. And what we can do, or what can Epic do for us, is we are developing a lot of parts. For example, now we are developing our own scanner system with optical input, and we need always good components to do that.
One thing that for me it is super exciting is that from the very beginning you've been focusing on modularity. You've been focusing on modularity for many reasons, and I would like you to tell us some of these reasons. Why did you take a modularity approach?
Because it's easier to fulfill the customer needs. So every customer has different needs, and with this modularity, we can set them. We can fulfill these needs of the customer.
But do you expect for every customer to have a completely different laser machine for laser beam welding?
Because the variety is so huge. For example, we weld very small sensors or big bus bars, 4 millimeter copper deep, and radial welding, axial weldings. Every product is special. So this modularity is needed.
Fantastic. We have a question for you, and this question is coming all the way from Munich. Laser components. René, what do you have in mind?
So I was just wondering, I don't know if you said this, but which wavelength you use for the welding? Is this always around 1 micron, or do you also use green for copper you mentioned, I think? With which wavelength you have experience?
Yeah, thank you for these questions. I don't mention it. We tested also green lasers, but we only use lasers in the infrared spectrum because we only use deep penetration welding. So we achieve a vapor capillarity, a keyhole. And in our opinion, the green laser light is only with big benefit if you weld copper, for example, in heat conduction welding and not in deep penetration welding.
Okay.
We have organized lots of different events on laser beam welding, and one of the ideas that we are seeing now is the opportunity to use to weld different materials to each other. Is that something that you are addressing? Is that a concern, and how can you help your customer who had these kind of concerns?
We do a lot of mixture material welding. the main mixed material is aluminium to copper, which we can do in very different thicknesses, starting from 0.2 millimeters up to 4 millimeters aluminium to copper.
And of course, laser beam welding is only half of the thing. The other half is the inspection. Inspecting the welding and making sure it fits the right quality, it is the biggest concern of your customers. Do you help your customers on this? Is that a solution for their headaches?
Yes, there are different types of testing the weld seam. Most of the times we use helium leakage testing to show the high quality of the weld. And we also use image correlation during the welding process to measure the keyhole dimensions. And if there is an event, the keyhole dimension changes and we can detect this very good. So it's an inline process control.
Christian, congratulations on what you have achieved, which is to put a new full modular turnkey solution in the market, fully reconfigurable for laser beam welding. What a fantastic event. What a great 6 presentations, what a great 6 developments on the photonic industry. We heard from Luxinar, Laser Components, AEMtec, Focuslight, Phasics, and LaVaCELL. I will tell everyone that the most important part of every meeting happens after the meeting is over. Now the ball is on your court. Follow up with the companies that think they can help your business, because it's all about cooperations. My name is Jose Pozo and my email address is jose.pozo@epic-asoc.com if you want to get in touch with any of the participants today. All you have to do is send me an email and I will be more than happy. I will be so happy of making that introduction to help Photonics being sustainable in Europe. I'm talking on behalf of a fantastic team of experts that make the epic dream a reality. Until the next time, I only want to ask you 3 favors. Wash your hands, wear a mask, and make sure that soon, very soon, we'll be traveling again and seeing your location. Until that time happens, see you soon. Bye-bye.